In today's video, we're going to look at conical column headers or slab thickenings for the column header. And if I rotate my 3D view, we can see what we're dealing with. So we've got a column. It's 1,000 millimeters in diameter. Above it, we've got a column header, uh, shear column header. And I've used the ELD in the profile catalog. So if we just click on it, it's under circular sections ELD. And instead of having a elliptical shape, I've made the D and the R the same value so they turn out round. And it's 1,000 at the bottom and it's 3,000 diameter at the top. And then we just have a simple slab on top of 400 millimeters. So we're going to attempt to reinforce that. So what I'll do is I'll just drag a image. So this is a screen capture of a um, when I did my prep for this video, I just grabbed the screen capture because I didn't really have a good example. But basically what we're dealing with, we've got a column with some ligatures around, and then the column has a cranked bar, and the main bars that goes up the cone laps with the cranked column bars, and then it extends right through to the top layer of the slab, and it will form the third layer of the slab. We also have some distribution steel going horizontally around the cone. So this is quite a complex exercise in the sense that the geometry is not simple, and I am going to use all three the rebar types, namely single bar, rebar groups, and rebar sets to accomplish this. And sometimes you do need to revert to more than one method to solve your solution. And let's see how that's done. I think for this exercise, what I will do is I'll start with a cone. We'll do the conical part first. So I'm going to open up a view on gridline 2. So if I go to my views and I'll just grab gridline 2. Also, if you look at the way I've put out the grids, we've got a 0 level here. We've got a 3.6 meter at the base of the cone. We have a 4.6 meter, which is a meter difference to the top of the cone, which is the soffit of the slab, and then we have the slab at 5,000. So what I'm going to do to work with the cone, I'm also going to open up a layout on 3.6 and 3.6 and 4.6. So if we go to the view list, we're going to grab 3.6 and 4.6 and drag them across as well. And then what I'm going to do is I'll go back to the grid line 2, the elevation, and under the visibility group object, I will also isolate the cone, so we only see the cone. We might as well do it for the other two views as well. So in here, make sure we've got the cone, and then in this one, also make sure that we've got the cone. Great stuff, and I'll go Control P. So in this one, you can see this is 3.6. So we're basically working at that level there where that dotted circular line is. And if we go to, this is the elevation on the side, this is the 3D view, I'll kill that one for now. And at 4.6, we're basically working on this level of the outer cone. Right, okay, so let's go to the elevation. That's the easiest place to start. And what I'm going to do is I'm going to start with the horizontal bars. Now, with the horizontal bars, it's going to be 16 millimeter diameter bars. It's quite tricky because if we put in a crossing bar and we just click there, we can see we get a really funny shape. And you can control it by moving your offset around, but it generates let me show you. If I go here and I switch on our visible leg visibility and I click on the bar, it does generate an immense amount of faces, and that's what we want to manipulate at the end of the day. So what I'm going to do is I'm just going to delete those. I'm going to go Control P, so we're back on the elevation straight up again. And for this exercise, I'm actually going to use by face. And when I go to face, you can see as we hover around these faces, it actually gives you the direction of the bar. And if we pick the one just off center from this and we hover towards the bottom point, you can see we get vertical bars. Or if we go towards the side, we get perfect horizontal bars. Now, if I click that horizontal, Tekla will generate, and I'll just quit out of the command there. Tekla will generate this sliver of reinforcement because it's only picked one face, and that is okay. Now that we've got that selected, what we can do is we can go up to the top here and say add a surface. And if we click on the outside surface, we then add surfaces right around. And then the important thing is we now have two faces on top of each other here. We've got the surface here, but we've got the face here. So we've got to click on the face. Just make sure that you select the actual face. If you click on it, Tekla will tell you actually a rebar set leg surface, and you can just delete it. And that was the wrong one. So if we just click on the bar again, it's so important to make sure that you select the right one. It will actually highlight. So if you look at that, you can see it's actually now highlighted. And then if you delete that, we're left with the surface with the bars in it. And the reason why they're so funny, it's because the guideline is at the slope of the cone, and rebars always produce perpendicular to that. So that's the next step in this exercise. We need to fix that up. So if I just do a redraw to get our cone again, and I click on our rebar, we can see the first step is, I'll switch off the faces, is to get that guideline perpendicular. So what we can do is in this elevation, we can just drag it so it's perpendicular or in line with the grid line. It's vertically up. And then if we go to the top view of the 3.6 level, this view, if I grab this one, it is the bottom. I can grab it to the middle of the column. And then if I go to the 4.6 meter one, I know it's this outside one. I can drag that to the center too. And as soon as I do that, you can see how nicely that reinforcement's actually, and I'll just do a redraw, how it's gone horizontal for us. So if we look at the elevation, we can now see we have this guideline exactly in the middle of the column going up and down. So all this reinforcement is then being created perpendicular to that. And that gives us this perfect circular reinforcement. Now, at this point, we can't see where it starts and ends. So it's a perfect circle. We need to split this up into, workable bars. So if we go to level 3.6, which is the bottom of the cone again, see my title bar at the top there, we can now split this. So if I click on this bar, I can then go splitter, and I can make sure that I load my defaults. I want a standard lap. And now what I can do is, actually we can't see the bottom of the concrete here. So what we can do just before we split it, let's just temporarily select this reinforcement and then say give us 150 offset on either side, just to so we can see the concrete line. As soon as I do that, I can see the concrete line. We'll rectify that in a minute. So if I click on the reinforcement now and I go to splitter, I want to split the bottom, start at the bottom, so make sure you're on 3.6, and then we can pick this point of the concrete here. And before we pick the other, and maybe I should just mention now, the reason why I can actually split is because I'm in the multi-point mode. Maybe what I should do is just show you, if you are in this mode, you cannot split. Even if you click, Tekla doesn't do anything. You have to be in multi-point mode when you're working with tapered or guideline bars. So if you're in multi-pick mode, we can now select the bottom because we know at 3.6. Click the bottom, and to click the top one, we want to be in the right Z direction. So we flip over to 4.6. And now if we click there, we know we're going to click at the top. So as soon as I click there and I say OK, Tekla's now split those bars for us. And if I just go into 3D quickly and have a look at it, we can see that these bars are all now been split. And now we can do the same on the other side. So I'll go back to my 3.6 level, click on the bar, click on the splitter, start at the soffit of the cone, flick over to level 4.6, click on the top of the cone. Middle mouse button, now it's split. Now if we look at this in 3D, I'll just switch my highlighter off for a minute. If we look at these bars in 3D, we can now see how nicely they lap. And I think what we need to do now is just go back to our elevation, go Control P to get it perpendicular to the plane. And now what we can do is just click on the bar and say we want 100 millimeters from the top and from the bottom. It gives us a bit of workspace there. The other thing we need to look at is these spacings. At the moment we've got 200, but the 200 will be calculated upon this vertical guideline. The engineer might ask for this distance. So what we can do in here is to just try 150 to start out with as a slope distance. And now if we go F and measure a distance from this point to this point, we get 188.56, which is closest diameter to 200. You know, you can play around until you get 200 there, but you're going to drive yourself insane. The engineer is asking for 200 as a max, so he'll be quite happy with 185, and the bars work out nicely. Now, with those bars done, we can now click on the cone, right-click, inquire, go to cast unit, and have a look at the bending schedule. Now, in here, you can see we've generated a shape code that says RS. And the size of the bar is a 12mm bar. I wanted 16, so we need to go and fix that up. And then you can see they're all grouped by 2, 2, 2, 2, 2, 2, which means that Tekla was smart enough to recognize that these two at the bottom, this one and this one, is same. These two are the same, these two are the same, these two. But that's as much as you can optimize, because the radius is different. Even if you apply a tapering ruler, it will not work because the radius on each one of these are different. And those two are already the same, so you can't further optimize this. So it's really good the way that Tekla deals with this. But that is my sort of take on how to deal with these sort of bars. It's a bit of a workaround by starting with a face, then adding a surface, and then go delete the original face to get this. There is no other way that I've found with rebar sets that you can easily get around that solution. Rebar groups does not provide you with the solution. These group bars and circular bars are linear bars. They have no tapering option. And even if you do guidelines, it's a bit of a problem because your guidelines, they don't really want to go right around the column. So I found this a very good way. It's also the only way that I could come up with that actually generates exactly the same bar per plane. So with that said, final tweak is just click on it, and then we'll go for a 16mm main bar, and I am going to change this to a different color, and let's make it the 8 color, class 8, modify, and we're good. Now the next step with this is to do our main bars. It's the bars that we will that will be radial around the cone, and for this I'm going to stay in this elevation, and I might just add all the elements to it. Control P, so we can just see what we're doing. Now the first thing I'm going to do is I'm going to draw a construction line, and I'm going to make sure that I've got enough extension, like 1000mm, and a solid line so I can actually see it. And then I'm going to pick this point, and I'm going to pick that point. Now that construction line will be drawn on this plane, the plane that the grid is in. If we just flick around, we can see where it's drawn it on that plane. We just mark it in case it doesn't show up on the video. But you can see it's actually drawn it on that plane because we were in Control P. And the reason why I need that is because I need to see the extents of this conical bar that I'm going to put in. So for that, I'm going to use a single bar. So we use the Greebar sets here. Now this one is most easily done doing a single bar and then using the array tool to radial it around. That's by far what I found the most effective way to deal with this. So if we go to a single bar, and then again we just go and load our property. So this time we'll go for a 24 main, and for the class we will go say 7 and leave that alone. Let's leave all of this alone. We'll see how we can set those. Now the part to reinforce is the cone. So I'll just put my highlighter on again so I can see what I'm selecting. There we go. Click on the cone, and then Tekla is asking for the shape of the bar. So the shape of the bar is, we're going to start with a rough dimension here, or a rough leg there. We're going to go up all the way to the top of the slab, and we're going to give it a rough dimension there. And then we're going to middle mouse click, and Tekla will draw a bar that looks like this. Now in here we can already see we've got some cover issues. This needs to be the opposite of what it is. So if we click on the bar, we can see that's 25, 25, 25. Now this is leg 1, leg 2, leg 3. So we know leg 3 is correct. So what we can do to start out with is we can say, okay, on the on-plane settings, we can say that, I'll just move my mouse a bit. We can say that the first leg's got to be a minus 25. So is the second leg. And the last leg can be a plus 25. So as soon as I do that, it's now got the cover correct. All we need to see is the dimension value. Now, I anticipate putting in 16mm diameter bars for the ligatures in here. So we need to add 16 mils to this. And for this one is a bit different. So if we grab the first one plus 16, so for the first one we can do 41. So if we, instead of saying 2 times 25, what we can do, and I'll move my mouse again, is we've got minus 41 for the first one. For the second one, we need the minus 41 times, we need another plus another, and I've actually made a mistake. So it's 25 plus, beg your pardon, it's 25 for the cover plus the bar diameter. Let me just clear all of this. So it's 25 for the cover plus I added 16. That's incorrect because the 16 bar has got a 19 diameter. So it's plus 19. So the first bar will be 44 and then plus another 19 for the second one. That's 63. Now, how did I get to that? Let's just first key them in before I forget them. So the first one is 44. The second one is 63. And the last one for now is 25. So as soon as I enter that, you can see that we get the 63 over here. If I click on the bar, we get the 63 over here. We get the 44 there. Now this 44 is made up by the 25 cover plus the 16 bar, which is a 19 diameter. So it should come in right in the inside of that leg. This side I use two 19s, and the reason for that is if you look at this lap here, and I'll just rotate the bars slightly, you can see that Tekla actually stacks them on top of each other. So to miss them, I've just added another bar to it, so it should run up the inside of the top bar. All right, so now at the top, we'll deal with that cover as soon as we put the slab reinforcement in. So for now, let's just see what that bar looks like from the top. So if I hover over to my 3.6, we can see this bar is actually sitting off the grid line. It's got a 25 from plane, so the from plane we can make 0, so it's sitting straight on the grid line now, and the on plane dimensions remain. Now the only thing we need to look at is the leg length. So at the moment, yeah, it's sort of, we don't really know what that is, and we don't really know what that is. It's just arbitrary dimensions. So what we're going to do is we're going to force them. So in the start and end, we're going to pick it as a leg length rather than a cover. And for the leg length, I'm going to force it as an 800 millimeter leg length and an 800 millimeter leg length. So as soon as I do that, Tekla now fixes this leg and that leg to 800. So if we click on the bar, right click and inquire, we can have a look at the bending schedule. So the start leg is 800. The diagonal intermediate leg is 1863. And then the last leg is 800. And these two values are the offsets to create that. So that bar is now 100% correct, and we can look at the final cover at the top of the slab as soon as we put in the slab reinforcement. So to get this bar to radial now, what we can do is again flick over to our 3.6 level. I'll do a redraw and just click on that so it can repaint itself. So for this, the best way to do this is to use the radial array tool. And the reason I'm saying that is any changes made to this bar will be reflected to the others. Now, the tricky part with this is that the engineers asked for these bars to be radialed around this cone at the top at approximate 3 or 300 millimeter spacing. So that will also be a maximum, not a minimum. So if we look at this cone, if I just click on it again, we can see that the top is 3 meters and that's a diameter. Now, if I just grab my calculator across here again, and I'll just clear everything. We know from school that pi times diameter will give you the circumference. So if we go 3000 and we times that by pi, okay, that will give us the circumference. And if we divide that by the 300 spacing that the engineer wants, we are left with 31 spaces. That means 32 bars. Okay. Now knowing that we're dealing with 32 bars, what we can do now is we can go 360 degrees divided by 32 bars, gives us an angle of 11.25 degrees. Okay, so let's see how we can use that. So if I go to our applications and components and I type in array, we can see the radial array tool here. If I double click it, we can make some changes. So the first thing is we know we've got 32 bars, so we've got to generate an additional 31. And the angle, as we've just worked out, must be 11.25. And then we can apply that and say, okay, and now Tekla is asking, pick the objects you want to copy. So I'll hover over the bar, click the bar, and then middle mouse. It asks me the origin. We'll pick the center of the cone. The X direction is this way, and the Y direction is that way. And there we go. It's now generated all those radial bars based on this bar. And remember, any changes we make to this bar will be reflected there. And let's start by taking this bar, and I'll go back to properties and just changing its class to a 4 and say modify, and you'll see how that works. And just like that, it's updated all the other bars. That's why I say that's a very effective way to use this. Okay, now that we've done those radial bars, we can actually see how nice that's looking. Is we can just get rid of this construction line. And what we can do now is I think in this, we can just quickly show all our elements. And we've got um, um, a depth problem here. If we put on the scissors, you can see where it's cutting it off. That's why we're not seeing the slab. So I'll flick across to the upper view. And this view, I'll just turn it around a little bit. And then what we can say is give us a crossing bar. Now I'm back to rebar sets. And this time I'm going to say give me a 20 millimeter bar. And I'll make this bar green. And I will use the 100 offsets of either side again. And then for the creation, I'll just go for a target spacing of 300. Simple as that. So we'll leave it like that. I'll hover over the slab and I'll pick the top and say OK. I'll hover over the slab again. I'll pick the bottom and say OK. That gives us our two top layers. You could also obviously use by face if you want. And then we can hover to the other side. And this time I'll change my color to red. I'll pick the top and say OK. And you can see how Tekla deals with layers. Click on the slab again, click the bottom and say OK. And just like that, we've got our two layers ready to go. Now, if we go Control P and look at the elevation again, we can see the mesh with the cover. So the first thing I want to do is I'm going to flick these bars around. I'm going to click here and down in our contextual toolbar, I'm going to say move this to the outer face. It swaps those two layers around. I'll click on this bar, move to the outer face. It swaps those two around. Now, this bar, now you can see this is the array, that's the component, and this is the bar that we generate our information from. So it's important that if you want to change this, you need to change that single bar that we've put in. So yeah, we need to have a more cover. I want that bar to slot in beyond the second layer here. So how do we work that out? Okay, this is how we work that out. Let me just go back to my calculator. So we know, and let me just clear everything out again. We know we've got a 25 cover from concrete. Plus, we know those are 220 bars. So a 20 bar has got a 23 millimeter diameter. So we've add 23, plus there's another one, add another 23 equal. So we've got 71 millimeter cover that we need to add to that bar. So if we now click that single bar, and we know this is the third leg, if we go to the third leg, instead of 25, we plug in 71, we go modify, we can now see that that bar is now slotting in exactly underneath those bar, and it's replicated that setting right through the radial array. So all the other bars are perfectly aligned as well. Now that pretty much wraps that part off. So all we need to do now is look at the column. Now for the column, I'm also going to open up a view at 0. So if we go to view and we go down to view list and we go down to 0, open 0, I want to draw the ligatures for the columns here. Now I use rebar groups for the linkages of the columns. You could use the column component. So if I just go reinforcement and I scroll down to our catalog and we look at our circular column reinforcement here, you could use this, but the problem is just what we have if we go down to this view is we've got bars coming up here cranking into these. Now, and the column only stops at the top here. You're going to have dramas if you see, because you don't have an extension here. This is going to be a negative value because you want to stop it short. And these values here require a value above. And as soon as you try and tweak this to suit that, this component will break. You'll get sticks inside your component. So this component is not suited for what we want to do here. So the result is we're going to do it by hand. And I'll show you a very easy way to deal with that. Okay, so let's go back to the 0 level. And then what we're going to do is go to rebar, go to rebar groups, go to our circular bar groups. And then in the properties, we are going to pick a 16 millimeter tie strip. I will make the color 5. It's a normal group. Let's add a 180 hook to that ligature so it can hook around the main vertical bars, and we'll leave the other settings as is for now, and the spacing as well. So click the part we want to reinforce. Object not found. Click it again. Okay, now it's found. And now what we can do is Tekla is asking for the 3 points for the bar. So we can click the first point there, the second point there, the third point there. Now it knows what the bar looks like. And now it's asking for the 2 points. So we can just start on this point. And then I'll flick over into a 3D view. And it's very important that if you go up here to make sure that you snapped, you can see the blue ortho mode. Make sure you snapped in ortho until you hit the top, and you can see the 3.6 meter long column there. And once I click there, it generates the ligature for us. Now, we've got the two hooks overlapping each other here, and if we click on the bar, we can see what's happened here. So that's our point, our start point of our bar. And if we look at the start and end point definitions here, we can see that at the start it's got a 0. That's why it's just like starts there. And for the end, it's overlapping by 150, so it's going 150. Now we know from a 16 millimeter bar requires about a 700 lap. So what we can do is we can say 700 divided by 2 is 350. So we go minus 350 for the start and then minus 350 for the end. And once we do that and say modify, we then get a situation where we've got these hook centered with a 700 millimeter lap, centered about our start point when we started drawing the reinforcement. Okay, with that done, we can now start focusing on the elevation. Just look at the set out quickly the spacing. So first off, what I'm going to do is the from plane, that's the bottom and the top settings. I'm just going to make them 50. So it just drags the reinforcement a bit off it. And then for the spacing, I'm going to go exact spacing. So now this is, I normally just wing it a bit, yeah. So what I know is that the cover for the lap length on the main bar is going to be plus minus 1,000, and the spacing over the lap is normally half the spacing of the main spacing, being 300. So we're looking at 150. So I'm just going to go with 7 times 150. And then I'm going to say, I'm just going to plug in a value of 3 times 300 for the main. And then at the top, I know I want 3 bars at 100 millimeter spacing. So once I do that, you can see we've got our 8 bars over our lap zone. This is need to be tweaked, and we've got our 4 bars over our top zone. So all we need to do is just fill in the blanks here. Let's try 5. No, and let's try 7. And that's it. So now we've got our 4 bars at 100 millimeter spacing at the top of the column. We've got a spacing at 300 in the middle, and we've got our half spacings down the bottom where it's lapping with the starter cage. So now the last thing we need to put in is the crank bar. And again, yeah, I'm going to do a bit of a strange one. I'm going to go for a single bar. I'm going to change the color to let's take a radical color. And then for, well, let's go yellow so it shows up nicely against the blue. It's a 24 bar, we're happy with that. And in yeah, I'm just going to go back to the default settings. Cover 25. Okay, so let's just leave it like that, and we'll see how we can fix it. So the part we want to reinforce is this column. We click on the column, and then the shape of the bar. Now we know we've got a crank bar. Now crank bar's got 4 nodes, so let's just put them all in line and we can tweak them. So if I go here, start there, and I can go up to here somewhere. And now I know for the crank part, that's going to be the next node. For the crank part, I know that it's normally 10 times the bar diameter, and the bar diameter is 29. So if we go 300, or if we use the not the actual, the nominal diameter, it's going to be 240. So we can go to 50, for instance. It's, you know, you've got to apply your own standards there. And then we go to the top, and if we say middle mouse, we get a perfectly straight bar, but we've got 4 nodes. Now the first thing we want to do with those nodes is that we're going to push these 2 in. So if I grab highlight the bar, grab your alternate key, keep it in, and just select over those 2 nodes, it will tell you down the bottom you've got 2 handles selected. What we can do now is right click and say move special linear, and we're going to move in the X direction. And how much are we going to move? First of all, we're going to move negative. And how much are we going to move? We're going to move a diameter of a bar, and it's the actual diameter. So it's a 24 bar, which means it's 29. So if we go 29 millimeters there and we say move, we get the crank bar as we wanted. And now the last thing is we need to look at cover. So if we click on this, we can see this 25 is wrong. That's got to be, you know, the on plane's got to be negative, and the negative is got to be 25 plus that actual bar diameter, which is 19. So that will give us 45, so it's 44 minus. So as soon as I do that, we actually get this bar now. If we look in 3D, we get this bar sitting exactly on the inside of that ligature, and it's sort of sitting not in line with that bar. And the reason for that is if we take that bar, Control P, we go to a layout from the top, and then maybe what I can do is let's go for this layout, Control P, this 3.6. If we look at it now, we can see this bar is actually sitting off the X again. So to fix that again, all we need to do is go to the from plane value and make that 0. Now that bar is moved in onto the grid line, and now if we look at it, we can see those two line up perfectly. And the crank is also precise, and it sits nicely in ligature. Now the only thing really that remains is the radial array tool again. So if we go back to our radial array tool, go in here, ARA, and we double click on our array tool. Now we know that there's 32 bars in here. The engineer is asking for 16 bars in here, which is also every second one. It sort of makes sense what he's doing. So if we go, we need 16 bars in the column. We know that the additional that we have, because we've already got one there, we need 15 more. And then the angle is going to be, it's quite obvious, it's double what we had before. So that's got to be 22.5. And then if we say apply OK, Tekla is asking for the object to be arrayed. We hover over this bar, we click it, and middle mouse, and then the origin is again the middle of our column, and then the X direction like before is this, and the Y direction like before is this. And then if we look in here, Tekla has now generated these little yellow bars, and maybe that's not very clear. It's generated these yellow bars for us. Every second bar, it laps precisely as a crank onto these radial bars. And just like that, we've now completed our column with our cone and our top reinforcement. So what I'll do, I'll go to view, and I'll go to view list. I'll open the rendered view, and I'll get rid of the other views. And now if we go into a control 1, so we only see the reinforcement, I'll also switch off my highlighter, and that's basically H toggles the highlighter on and off. We can look at these bars and we can see how beautifully they actually work. You know, this sort of bar supports the top layer. It comes down straight and it cranks, it laps very nicely with the main column reinforcement. As you can see there, the crank really works well. And then we've got the stirrups for the column, tying the column nicely together. We also have these two circular bars that sort of tie the cone together, and that's pretty much it. I mean, if you have concerns about the conical bars, whether they will fit or not, what I always do is I'll just, I'll go to my rebar, and to the visibility, I'll make sure that I've got my splitters switched on. I'll switch off my guides, and then I'll grab these two splitters, and all I'll do is I'll go to properties, and I'll take the standard lap and I'll make it a custom lap, and I'll just give them a little bit of grace by saying, give me an 800 lap, please. Now what that does is it just extends the lap a little bit. So if they go up and down a little bit, they're not going to run out of minimum lap length. So that's probably a good practice to do. It doesn't add any significant number of tonnage to, I mean, it's really, you can neglect that, but it's a good, it gives the guys on site a little bit of tolerance to work with. But that's the conical column. I think it came out great. A very easy way to model it, and I hope at least from the techniques I'm showing you, you're learning something from this, and hopefully this is showing you how you can combine three types of reinforcement, namely single bars, rebar groups, and rebar sets to achieve a goal. Sometimes it's needed. I'll see you in the next video.